To be teaching you on the importance and the meaning of significant figures, also known as sig figs. Sig figs is important because the number of your significant figures is directly linked to a measurement, and using the correct sig figs determines getting the question right or wrong. To start off, I have two pictures of a beaker and a graduated cylinder that you would measure in the lab, and I'll show you how to read them. So, here you have, go to a beaker. As you can see, the measurement is in between 40 and 60. Those are the two numbers that it gives us. On a beaker, the smallest division on this beaker is 10 milliliters, so we can read the volume to 1/10 of 10 milliliters. I would estimate that this beaker would have about 47 milliliters, but 46 and 48 milliliters would also be correct guesses or estimates. Next, I have a graduated cylinder. As you can tell, there's a lot more numbers on the graduated cylinder. There's a lot more marks on the graduated cylinder than on a beaker. On this graduated cylinder, you read from the bottom of the meniscus. The meniscus is the curve where the water is on the inside the graduated cylinder. An appropriate reading of this would be about 36.5 milliliters, but 36.6 and 36.4 are also correct. So the graduated cylinder has 3 significant figures compared to the beaker, which has 2. Next, I have some problems that are examples of significant figures. So the first one is addition. As you can tell, you're adding 3 numbers together, and your answer ends up as 3 significant figures because one of the numbers you were adding had 3 significant figures, so you round. In subtraction, here we're subtracting only a number from another number, and you end up with 3 significant figures because the 0 does not count after the decimal. In multiplication, when you multiply 2 numbers together, you always round to the lowest, so one of the numbers you're multiplying has only 2, so your answer has 2. In division, you also round to the lowest, so one of the numbers you're dividing has 3 significant figures, so your answer also is rounded to 3. Continuing on, some more important rules about significant figures is that leading zeros are never significant. Embedded zeros are always significant, so that would be like 0.308, the middle 0 is a significant number. Trailing zeros are significant only if the decimal point is specified. So a hint for that is change the number to scientific notation, which is easier to use. One of the examples I have is 0.00682. So in this number there are 3 significant figures. If you want to convert to scientific notation, you get 6.82 times 10 to the negative third. Another example, 300. This has only 1 significant figure because the zeros after the 3 aren't significant. The scientific notation would be 3 times 10 to the second, or squared. One more example, 300 decimal. So it has 300 and then a decimal after. Because of the decimal, all 3 numbers are significant. And the scientific notation would be 3.00 times 10 to the negative, to the second, squared. One more example is 300.0. This has 4 significant figures, because again, zeros are significant in this case, and the scientific notation is 3.000 times 10 to the second, or squared. One last thing about significant figures is that when rounding off numbers to a certain number of significant figures, do so to the nearest value. An example of this is round to 3 significant figures. Round this number to 3 significant figures, 2.3467 times 10 to the 4th. The answer would be 2.35 times 10 to the 4th, because the 6 after the 4 rounds it up to a 5. And that is pretty much all you need to know about scientific notation and sig figs.